Good morning, all. My name is Melissa Townsend, Honorary Secretary of the JIE. I'd like to welcome you all to the first segment of JIE's fourth annual Developers Forum series. As you may know, this forum aims to enhance the knowledge of you, our participants, on the various permits, policies, and standards in planning and executing developments and infrastructure projects appropriately and successfully. So given all the structures being built in Jamaica of late, particularly in the Kingston and metropolitan area, we thought that we would bring someone to speak on one of the critical stages of building construction. So we have invited engineer Clyde Gray. Engineer Gray actually hails from the parish of Clarendon, Jamaica. He attended University of Technology and Florida International University and holds a bachelor's and master's degree in civil and geotechnical engineering, an honors diploma in structural engineering, and a diploma in computing and electronics. He's a licensed engineer in the state of Florida and a member of the American Society of Civil Engineers, and also a member of the Deep Foundation Institute. He's currently the Geotechnical Department Manager at NV5 Global Incorporated in Miami, Florida, and is also a PhD candidate at FIU. Engineer Clyde has over 15 years of experience in providing geotechnical engineering, foundation engineering, and materials testing and consulting services. His duties have included preparation of geotechnical investigation and foundation recommendation reports, determination of soil and rock engineering properties, engineering and supervision of load testing of deep foundation systems, seawall design and rehabilitation, and even pavement design, and reviewing inspection and testing reports for accuracy for a wide array of infrastructure and high-rise projects. Engineer Gray also performs analytical work using software programs, including LPIL, Seto 3D, and SoilWorks. Engineer Gray is experienced in all types of laboratory and field geotechnical work, including test borings, field testing, as well as inspections of various foundation types such as driven piles, drilled piles, helical piles, auger cast piles, sheet piling, and pipe piles. He has performed sinkhole investigations on various projects in Florida with the use of ground penetrating radar, floor elevation study, soil test borings, and even visual observations. Engineer Gray has also worked on several projects in New Jersey and New York. He has also worked extensively in the Caribbean, providing geotechnical engineering, foundation engineering, and material testing consulting services. So when Engineer Gray, when he's not playing in soil, he's actually spending time with his wife, Dr. Keisha Gray, and son, Chaz and Chad. So as you have heard, Engineer Gray is more than adept to speak on our topic today, which is high rise on the rise, geotechnical engineers rising to the challenge. So I'll now hand over to Engineer Gray to begin his presentation.
Let me say a pleasant good morning to the Executive Board of the Jamaica Institution of Engineers, all members who are part of the Jamaica Institute of Engineers, all members who are part of the discussion this morning. Let me say a pleasant good morning to you all. I like the introduction that I have gotten. However, I don't like to rule out my high school, Edinburgh High School, because all of my formative years were at Edinburgh High School, and I am who I am today because of the background I got at Edinburgh High School. So I always emphasize Edinburgh High School. Today I want to share a little bit with high rise on the rise in South Florida. As I realize many Caribbean countries have now gone the route of installing or doing construction of high rise towers. And I recently saw where Jamaica is now going the route of going 20 stories and above with towers. So I just want to share a little of the experience that I have had working here in the United States on different high rises from anywhere from 10 to 93 level buildings. So my topic would be high rise on the rise in South Florida, a geotechnical challenge. For those of us who are geotechnical engineers, the very first day we decided to be geotechs, that's the first challenge that we have. And the challenge that we have is that we, at some point in our career, has to provide background information to all other engineers, whether it's a structural, transportation, mechanical, hydraulic, earthquake, environmental, construction, and even the geologists themselves. We have to provide some information to them. So that's the very first challenge we have, the very first day we sign on to become a geotechnical engineer. With the growing rate of the population in South Florida, so does the demand for water, land, trees, fuels, housing, and infrastructures. Cities such as Miami, Fort Lauderdale, and Palm Beaches, with their prime locations, sceneries, and cultural diversities, have become growing resorts where developers have invested heavily in the construction of high-rise structures, and these include luxurious hotels and condominiums. One of the challenges that they face in these areas is that there's not much undeveloped lands, or they are very small spaces and they have to redevelop these. Now, how they get around this is that they maximize space by maximizing with height and depth. That is very, very tall towers, and they try to go as deep as they can underground. Also, another challenge faced is climate. Climate change brings about droughts and flood. Flooding, in most cases, creates a rise in the water table, which brings about the need for dewatering or groundwater control during construction. Now here I just show a quick example of the tallest tower that has been constructed, tallest residential tower that has been constructed south of New York. It is known as Panorama Tower. It is 85 stories high, with the tallest point being 868 feet or 265 meters. In 2019, it received an award of excellence from the Council on Tall Buildings and Urban Habitat. Also in 2019, NV5, that's the company I work at, was recognized for its geotechnical capacity. Some engineering challenges that the geotechnical engineer would be required to provide solutions to. These are some of the challenges that we face when a tower of a certain height is to be developed. We have to make sure that we have safe and economical foundation to support these structures. The settlement, that's total and differential settlement, are acceptable, because if they're not acceptable, then it could be very costly for the developer. We have to make sure that the settlement impact to adjacent structures are minimal. We have to make sure that the vibration from the construction of the tower is also minimal at the adjacent properties. And we have to make sure that the excavation and ground movement at adjacent structures are properly taken care of. Also, basement construction itself is another problem, because South Florida, the water table is pretty high. Within the first 2 feet of digging, that's pretty much the water table here. So you can imagine digging 10, 15, or even 30 feet underground, the volume of water that you have to deal with. And there are so many stringent regulations when it comes to dewatering a site, where the DEP, that's the Department of Environmental Protection, has certain limitations on where you can deposit water once you take it from your site. So it creates a very problematic situation for these towers that needs to install basement. Also, deep pile caps and elevator shaft, similar to basement excavation, because they go underground as well too. So the first thing we do, we determine the foundation selection. So auger cast or continuous flight auger cast, augered cast in place piles is the most appropriate type used in towers in South Florida. Some of the advantages of these foundations over other foundations are: one, it does not require casings or slurry. The rate of installation is much faster, meaning you can install many auger cast piles within 1 day. It is much more economical, and on any project you can use different diameters. So you can use as many diameters of piles that you want, also different lengths. Some of the disadvantages: it's a very messy operation. The spoils have to be properly disposed of, and the reinforcement has to be installed before the grout starts setting. So can you imagine digging or augering down to a depth of 100 feet below grade, and as soon as you get to that depth, you allow that grout to start set. When you get to put the reinforcement in, it becomes very problematic. So in most cases, what happens, you have to abandon that loop, you have to abandon the grout that is there, and you have to reinstall. The grout intake can also increase depending on the soil type. So if we have organic material, then your grout intake typically increase. The piles cannot be installed close to one another until it has set. So there's a certain requirements of how close you can install one pile to the next. and the piles can easily get out of tolerance. So if the operator who's operating the machine is not skillful enough, then they can have that pile sometime, you know, an inch or more or out of tolerance. One of the benefits of auger cast in place piles, we call it ACIP, is that it gives you a wide range of diameters to use. So you can go from 14 to 36 inches or 36 to 92 centimeters. And you can go from 10 to 200 feet, that's 3 to 60 meters in length on the ground. The capacities on these piles typically range from 80 to 4,200 kips. That's 356 to 18,683 kilonewtons. The tension capacity typically range from 45 to 55% of the compression capacity. So once we determine the compression capacity on these piles, we typically range the tensile capacity as a 45 to 55% of that capacity. For lateral capacity, it's typically 0.5 kip per inch of diameter. Once you're in sand, silty material, or clay. So if your head of your pile is in silty material, clay, or sand, then we can use a rule of thumb that the capacity on these piles would be 0.5 kip per inch of the diameter. And for gravel and rock, it's typically 1 to 1.5 kip per inch of diameter of those piles. And these capacities typically are verified by load tests. So one of the reasons why we don't use drill shafts is that they are typically economically feasible. They are very attractive to carry large load, but they have a very slow installation rate. So one drill shaft could take you up to a day or a day and a half to be installed, while you could install 20, 30 auger cast piles within that period of time. So the slow rate of installation doesn't make it feasible for these towers. Other deep foundations such as driven piles, they are not considered, because of the noise nuisance, because remember, we're installing these towers in location to adjacent properties. So once you start driving, that vibratory effect from the driven pile tends to create damages to existing buildings. And with that vibratory damage to the existing building, it can become very costly for the developer, where later on they'll be into many lawsuits where they are sued by many different property owners for damage from their construction. Also, the limestone here in Miami can get very hard, and driving these piles become very difficult, and it's very hard for you to penetrate that deep limestone layer to get adequate uplift capacity on these piles. So here I'm showing an example or two examples of the continuous flight auger machine that's used to auger the piles in place. So once the pile augers to the depth, grout is pumped through a hose which is attached from a pump onto the machine. It's pumped and it's slowly raised until you get back to ground surface. After we determine the foundation, the diameter of the auger cast pile and the length, we do settlement and lateral analysis. So the settlement analysis we do to determine maximum and differential settlement, because those are very critical. We also determine the settlement using empirical formulas, as well as software programs such as Settle 3D or Midas GTX NX. So if we want more in-depth finite element analysis, we typically go with the Midas GTX NX. This is a time-consuming process, but we do charge good bucks to create that analysis. We also determine the rate at which settlement dissipates. So you want to know at what rate your settlement dissipates, whether it's 1 in 25 inch, 1 in 30 inch. So that way you can determine the settlement at your property boundaries and how that settlement may affect adjacent properties. Because one of the things now that they have implemented here in Miami is that on your property boundaries, you should try to have a minimum of 1 inch at your properties. It's very difficult with these towers going 70, 80, or 90 stories high. But that's one of the rules they are having now. So this finite element analysis becomes very vital, because we now can model different pile lengths, and based on the different pile lengths, we can see how your settlement dissipates as it propagates towards your property boundaries. And then for lateral analysis, we use what is known as the LPILE software, or if we're doing group, we use Midas SoilWorks. Here is, I'm showing examples of the profiles that we create once we're doing that Midas GTX finite element analysis. Each color block represents a different soil layer. And for each soil layer, we would have input depending on the analysis we're using, whether we're using elastic or white brown. We would put in different parameters for the soils we're using. Also, once we do our soil borings, we perform laboratory testing so we can determine our modulus of elasticity or unconfined compressive strength or splitting tensile strength that we typically put these values into the software. Here I'm just showing sections of the tower. So on the left, I'm showing a mat supported on piles, and this is for a tower by the name of Bentley Tower. And on the right, I'm showing the output that you get. I'm showing the contour lines and the color code that matches the different settlement that you get at different location of the tower. Also, what is critical is that we plot the settlement profile as it dissipates away from the tower, so we can see at the border or at the property line what your settlement is. So looking on the screen here, I'm showing the graph, and in the middle of the graph is the footprint of the tower. And then as you look to the left or the right, we are showing the distance away from the tower, and we're also showing the settlement away from the tower. And these are very critical to determine the effect that your tower would have on adjacent properties. Because one thing you'll realize is that once these towers are erected, then all property owners get in line, because one way or the other, somebody's going to have a claim for some damages to their properties. Once we have done our settlement analysis as well as our lateral analysis, we finalize on our pile size and pile length. Once that is done, we get into testing. So testing we could do in general accordance with ASTM D1143, and that's the compression load test. Depending on the capacity on those piles, we'll use either a standard top-down, a statnamic, or an apple drop arm. So the statnamic is like, it's created like a rocket. You put it on top of the pile, it has, all gases and all gravels inside of it. You light it and it explodes like when a rocket is taking off. Once it explodes, that thrust that it leaves behind applies a force on top of that pile. That pile would have had strain gauges inside of it that would have measured the side shear or the friction at different depth as that load hits the top of the pile. The same thing is done for the standard top-down. The standard top-down, you have loads that apply on top of the pile. You could do weights, or you could have hydraulic jacks that apply different pressures, and the pressures is correlated to the design load. You have strain gauges installed inside the piles, and the strain gauge would measure your side shear. And then based on your side shear, you can do value engineering to determine if your pilot needs to be extended or if your pilot needs to be shortened based on the load dissipation on the shaft of the pile. The apple drop hammer, it's a weight that is applied at a certain distance above the pile. It could be 10 feet, 20 feet, and that weight is dropped directly on top of the pile. Same thing, the pile is instrumented with strain gauges, and as that weight hits the top of the pile, that strain gauge or those strain gauge values are recorded, and once it's recorded, you take those values and you do analytical data or to determine if your piling is suitable and the movement of your pile. Another method we use is the bidirectional load test, or it's called an Osterberg cell. So the Osterberg cell is placed sometimes halfway in the shaft of the pile, and what it does is it applies a uniform load upward and a uniform load downward. Now, the Osterberg cell is typically used on these high capacity auger cast piles. So anything above 1200 kips design, you typically brings in the Osterberg cells and it applies the load, and then you measure your strain gauge values, and as well as it has telltales that measure the upward movement of the pile shaft as well as the downward movement of the pile shaft. And then we also do the tension load test in general accordance with ASTM 3699. 3689 would be your lateral load test, and the lateral load test would be used to justify the lateral analysis that you perform on your pile. A lot of time when these tests are completed, you can do analytical engineering to determine if your lengths are adequate, if your capacities are adequate. And a lot of time, the structural engineer will get back to you to say, hey, based on my new design, based on the materials that they are planning to take to the site, I may need an increased capacity on this pile. So one of the things that we typically do on these tests is that in the compression test, we typically go to 2.5 or more times the design load. ASTM requires you to go to a minimum of twice the design load, but we typically go to 2.5 or more for that reason of additional load on the pile requirement, as well as in most cases, some of these piles will be installed out of tolerance. Once it is installed out of tolerance, it develops eccentricity on the piles, and then it requires additional loading. So we'll have enough data to provide additional capacities on these piles based on your overload. Now, after we're finished testing the piles for any tower that involves basement, basement construction is a very difficult task. For basement construction, we have to give support to the basement excavation, as well as methods that will facilitate a dry basement excavation during construction. One of the basement support that we typically recommend is sheet piles. Traditionally, sheet piles are typically used to support the excavations. Conventional sheet piles are typically installed using vibratory hammer to send the piles in place. In loose to medium dense sand, these sheets can be pushed into place. The walls for the sheets can be cantilevered or anchored or braced. In a cantilever system, we recommend a maximum of a 10-foot height. Above that height, we recommend bracing or anchoring these sheets. Some of the advantages of the sheet piles is there are a lot of contractors here in South Florida who are familiar with the installation. It's very, very, very quick, and the sheets can be pulled if they are misaligned or if they need to be reused at another location. Some of the disadvantages: the sheets can get damaged during installation. The vibratory effect from the installation can have detrimental effect to adjacent properties. The sheets can have leakage or soil washout. And the depth of the sheet has to be considered because it can protrude into the excavation. So here I'm showing the two types of machine that typically used to install the sheets. Looking on the screen on the left would be the vibratory hammer, and on the right would be the pressing hammer. So one does vibratory techniques to install, the other is the pressing technique. Here I'm showing a complete project where we install sheets. So you can see on the ground that those would be your auger cast piles, and on the side that would be your sheet pile wall, and that's used to create support of your excavations. Most time when this is done, what they do, they add water barrier onto these sheets, then they put on concrete or shotcrete to create the walls, and then that would be your basement wall. Another method is deep mixing or deep soil mixing or deep mixing walls. Deep mixing has gained popularity in basement excavation in South Florida. This procedure typically uses large diameter paddles to blend a lean grout mix with in-situ materials to create a column of cemented material with unconfined compressive strengths on the order of 300 to 500 pounds per square inch or 2 MPa to 3.5 MPa. The mixed columns can be reinforced with steel sections added for excavation support. This technique is typically used for 2 or more levels of basement below grade. However, due to the very high water table in South Florida and the closeness to adjacent properties, because of vibration and water control, it is now being used more regularly on 1-level basement excavation. Here I'm showing the deep mix auger and the paddles that are used to create that deep mix wall. Here is an operation where that deep mixing operation is taking place. So looking on the screen to your left would be the deep mixing machine. To your right would be your tanks that keeps your bentonite or your water and your grout. They are mixed together and everything is sent to a pump, and then that pump sends it to the machine, and the machine then install it or mix it into the in-situ soil. So the advantage of this method, it's practically vibration free. So it doesn't create any vibration as the sheet pile does. It is well suited for subsurface condition where the soil is to be mixed or sand or weakly cemented limestone. If it's a silty site, then this process typically doesn't work very well in silty materials. It presents no intrusion into the excavation. So once you finish, you cut that wall and you cut directly at what spacing you require, and it's relatively watertight. Once it is finished, you have very minimal water leakage. The disadvantage is it requires specialty contractor. Locally, there is only 2 companies that are carrying out this operation, or 2 companies that are specialty contractor in doing the DM walls. It is very costly compared to other methods, and the drilling does remove some materials, so there is a potential for subsidence and offsite impacts during the mixed installation. So care has to be taken to stabilize the column being treated. So sometimes they treat it with water or bentonite slurry. Here I'm showing a picture of a project that we recently completed in Aventura. It's a 3-level basement. So you're looking at an excavation there of 30 feet below grade. And the water table here was 2.5 feet below grade. So 2.5 feet of digging, you're encountering water. So this is 30 feet below grade. So that's another aerial view looking at that 3-level basement. And this is looking at the basement wall. So that's how the walls are look once you finish your DM mixing and you cut into that basement excavation. Another system that we typically recommend or use is tangent and secant pile wall. So the same hourglass piles that we use, we create tangent and secant pile wall using the same machine on the site. So an advantage is it's practically vibration free. Large heavily reinforced sections can be installed if needed. So depending on the level of reinforcement that you need or the level of stabilization that you need, you can create large sections and you can heavily reinforce them. So in case we want to use these same piles to be bearing for foundation, then we can utilize them both as an excavation support, also as a foundation member. Some of the disadvantages is water tightness can be an issue. If they are not locked in properly, you can have water intrusion between the two. The pile diameter has to be considered because it can protrude into the excavation. Although installation of the piles can be achieved fairly quickly, you are restricted by how close you can install piles against each other. So this could become also a timely installation. So as explained, unlike sheet pile wall, where the face of the wall can be excavated immediately, once you do the tangent and secant pile wall, you typically have to wait 2 weeks or more to allow the grout to gain strength before you can do any excavation. Because if the grout doesn't properly gain that strength and you start excavating, then you may start cutting into the grout and then you damage the entire process and have to go all over again, which becomes a very costly process. So here I'm showing a schematic on the left-hand side of how a typical secant pile wall is done. And then on the right, I'm showing a section on a project of a secant pile wall excavation support. That's another section of the secant pile wall. Another method of support we typically recommend is slurry wall panels. So slurry wall panels are dug from existing grade and filled with bentonite slurry. So once the final depth is reached, rebar cages are dropped into the slurry and concrete is placed via trimming to displace the slurry. This method, like the DSM, is also better suited to deeper basement. Slurry walls can be incorporated into the foundation design as load-bearing elements. So the slurry wall is similar to the secant pile wall. However, the process is just a little bit different. The machines are different, the equipment are different, and the installation process is different. The advantage of this system, it's practically vibration-free in sands, because once you start cutting into rock, then it creates vibration, and then the vibratory effect can affect your adjacent property. It is suited for subsurface conditions where the soil is to be excavated are sand or silt. Some disadvantages: it requires specialty contractor. It is very costly compared to other more conventional methods. The walls can leak, and during excavation, the panel does remove material, and there is a potential for subsidence and offsite impact during mixed installation. So again, care has to be taken while doing this process. Here on the right, on the left, I'm showing the slurry, the machine that is used for your slurry wall. And on the right, I'm just showing a schematic of how it's done. So once the machine cuts that depth, the slurry is placed, and then once slurry is placed, the slurry is placed to keep the walls intact. The machine rises to the surface. Once it rises to the surface, concrete is placed via tremie into the hole, and because the concrete is heavier, it displaces the slurry. So the slurry rises to the top as the hole is being filled with concrete. Once concretes get to the surface, you see that clean grout flowing at the surface, then your reinforcement is typically installed. Another method which have been done only once is soil freezing. Soil freezing is a technique where very low temperature, vertical refrigerant filled tubes are introduced into the ground to freeze the soil. This technique is very costly, time consuming, and it has found very limited use locally. And the reason is it's very expensive. It is time consuming because the project we did it on was Brickell City Center. And on Brickell City Center, it took almost 6 months for that water to properly froze in the section that they did that test. So many developers and contractors stay away from this because 6 months of waiting on this would kill pretty much their project, because with these developers, it's a get out approach. So they want to get in today, and in 6 months to a year, they are getting out with their profits. Now, after we finish the pile selection, the pile testing, and the basement construction, we typically do settlement impacts, excavation and ground movement impacts, as well as vibration impacts. So these are key components that we take into consideration with all of these towers. And here we'll realize that attorneys are very, very vital in these projects. So every adjacent neighbor has an attorney lined up waiting on something to happen. So we make sure that these key components are taken properly care of or addressed properly during the design phases. So in settlement impacts, we have settlement monitors on adjacent structures. And there's a benchmark that we typically use. So any adjacent structure within 100 feet from the footprint of the tower is typically monitored. Or if it's within a 300 feet radius from the center of the tower, those adjacent structures are monitored for settlement impact. For excavation and ground movement, any excavation of your tower that goes as close to your adjacent property, you typically want to find out what the adjacent structure is like. So if it's a building supported on shallow foundation, you want to first find out if it's on shallow, if it's a slab on grade, and then if that's the case, you want to do mitigation. The mitigation typically include underpinning of these members using permeation grouting or chemical grouting to create stable support. So during your excavation, the supporting soil is not undermined and it creates damage to these buildings. For vibration impact, you typically have vibration monitors placed on these buildings, and then you have vibratory limits that you set. So in most cases, we use 0.5 inch per second, and then we have a threshold of 80% of that value. So at 80% of that value, you'll get a notification. That notification could be in the form of an email or a text message on your phone saying, hey, based on the work that you're doing, you have achieved 0.4. At 0.4, we have different requirements in place. So as soon as you hit certain values, these are the measures you have to take to ensure that there's no damage to the adjacent structures. So here, this is typically what we do. So on the left, I'm showing the development. So phase 1 development, that would be our construction site. And then the FCR would be the rail. So the rail would be an adjacent structure. the historic building would also be adjacent structure and the phase 1 development. So these are adjacent structures. So we identify the structures that are adjacent to your project site. And then to the right, we will tell the contractor or the developer that here is the locations that we want you to place your settlement monitors. Here are the locations we want you to place your vibratory monitors. So these locations, you'll have special equipment placed on at these locations, and then you'll have electronic recordings. They could be on time or real-time data coming to your cell phone or to your computer, or the data is taken on a weekly basis, as in the case of the settlement, and these information is transferred to you. And then once it gets to you, you make necessary recommendations if they are needed. So here we'll have the table 1. I'm showing you a typical protocol that we have. So this is for settlement. So we have a 0.1 inch. We continue to take reading as planned. 0.1 to 0.25. You increase monthly, you increase frequent reading frequently, and you monitor buildings for any sign of distress. So once your settlement has exceeded or within these range, then you typically start looking out for these actions. And once it gets above 0.25, you need to stop working. You now have to modify your means and methods of construction because you're now exceeding the threshold level of settlement on the adjacent property. And it's similar, it's a similar thing for your vibration monitoring. You have the event description, and then once it achieves or gets into that range, you have an action plan of how you mitigate the vibratory effects happening at your site. And once you start doing this, you'll realize how critical these plans are, because these plans allows you to properly monitor your construction as well as limit any distress that your construction may have to adjacent properties, and limit any payout that you may have to do later on in case of any damages to adjacent properties. Here I'm just showing just a few of the projects that I've worked on that are 30 levels and above. So we have Brickell City Center, 48 level, Icon Bay, 40 level, Jade Signature, 57, Chateau Ocean, 33, Panorama Tower, 85, Echo Brickell, 55, My Brickell, 25, Waldorf Astoria, which is the new thing coming in town, it's 90 level, E11 phase 1 and phase 2, there are 63 levels apiece. We have Aria Development, it's a twin 60 level towers. We have Aston Martin, which is 53 levels, Square Station, 33, Bentley Towers, 64, Baccarat Tower, 74. And these are just a few. Here is just a schematic of what Waldorf Astoria will look like. That's the 90 level building. It's breaking grounds now. We're currently doing DSM walls. And then we on all the adjacent structures to Waldorf, we have satellites monitoring the tilting. So we're doing tilt monitoring on these buildings. So what the satellite is doing is that it's giving us readings today, and it's comparing that reading with 1 year ago. So March 9, 2022 is being compared to March 9, 2023. So it does that on a daily basis. So every day it takes a reading, and it's comparing the tilting of that building today to what it was 1 year ago. So we'll have an idea of any detrimental effect that our construction may be having to the building. This is my presentation. Any questions?
All right. Thank you very much, Clyde, for taking us through that very exciting journey of geotechnical engineering, particularly looking at some of the varying strategies we have to address foundation design in South Florida, but of course it's transferable to us here in the Caribbean, in particular where we may have high water table issues or groundwater issues being close to the surface. Maybe not as drastic as Florida, but sometimes we may be building against the coast. And now we're seeing a lot of increase in the desire for these high-rise structures locally as well as regionally. On the call today, or in the webinar, we have persons here predominantly from Jamaica, but we also have persons here from Trinidad as well. And I can see a number of them in the chat, and I just want to tell them thank you very much for being a part and here with us today. And at this point, we want to allow persons to have questions. I saw a hand earlier that was Chase Stewart, and I also have one question online in the Q&A session here from an anonymous attendee. So I'll just throw that out in the meantime. So Clyde, they're asking in terms of underpinning. They're finding that to be usually an expensive option. Are there any other methods that could be used to address structures that may be experiencing some, probably some differential sediments or some other issues like that, for which underpinning may be one alternative? Could they look at any other options?
I mean, they could look at helical piles. So helical piles, you could look at helical piles, and here using helical piles, you work in conjunction with your structural engineer. So depending on access, your helical piles may have to be installed at a certain distance away from your footing, and then you use beams and transfer that load into your helical pile. So helical pile is another option that can be looked at. And some
yeah, go ahead.
Sometimes depending on the location and accessibility, your helical piles could work out a lot cheaper than your underpinning with growth.
Would that require a lot of space, since we're not directly beneath the structure, but we're offset? Does that require a lot of land space in that sense? What if we're in a...
No, because the helical piles, you can use a bobcat to do that installation.
Excellent, excellent.
But one of the key things though is on these adjacent properties, if the owners decide that they are not going to allow you to do anything to their structures, then you pretty much would have to install either sheets or secant piles to prevent any excavation protruding towards those adjacent structures. And that's something that we find happen here locally a lot, is that sometimes adjacent properties are not going to allow you to do anything on their property. So you pretty much have to utilize the end of your property to install measures to mitigate off-site effects.
All right, great. Thank you very much. I see Junior Bennett's hand up. Junior, feel free to unmute your mic and share your question.
Yes, good afternoon. Very good presentation. Just in terms of the level of analysis that is done in Florida, I'm concerned whether or not we would need to do that depth of analysis if we're, doing insulation, these kind of high-rising building in, say, for instance, in St. Andrew, Kingston. And my supporting question is, what type of infrastructure would be necessary in terms of fire safe, in terms of safety, the risk that comes with it? Because while this high rising is very good and recommended and supported, I mean, what other kind of development from a safety perspective, that needs to be there in case there should be a fire, there should be somebody chopping a building or something? What support do we need to think of as well?
Right. So on these structures, you have to have a key life safety plan, and the life safety plan include fire, natural disasters. So you have to have access route. So you have to have a fire access route. So if you have regular vehicle access to your development, you have to make sure you have a special access route for emergency vehicles. So on every project that is here locally, every tower, there is a special access route for emergency vehicles. So that's a key component you have to make sure that you have on these development. Also on these development, you have to make sure you have emergency exits, emergency exit routes. These have to be very, very, very critical. So if you have different doors, different locations where just in case there's a fire in the building, then this is your main access route. And your main access route should be one clear path from whatever floor you're at all the way outside, away from the building.
Yeah. So, excellent response to that as well.
Thank you very much.
You're welcome.
Any other questions that we have? Are we getting some positive feedback in the chat? I see one here from Charles Allen, who's in Trinidad. Can you speak to the legal requirements in Florida as it relates to the importance of the site investigation and ground monitoring? In the Caribbean, we struggle to convince clients or state enterprises of the need or importance of this activity to the design process.
Okay, so here in Florida, from the very minute that construction starts, from the very minute that construction is in inception, you have to adhere to a lot of legal requirements, because one of the things that we normally get a lot is we get requests from loaners, because a lot of these projects are funded by banks, or some developer has some hard money lender who is funding this project. So these loaners send a request to us as a geotechnical engineer to provide a reliance letter, and that reliance letter has to state clearly that based on our geotechnical investigation, the site is suitable to withstand this massive development. The settlement from this tower would be in an acceptable range, and there won't be any adverse effect from the tower. So your investigation has to be very vital, because if you don't find that letter sending to these loaners, then most of these developers, the loan doesn't materialize.
Very good. So it's tied to the financing of the project, which I guess now incentivize everyone to make this transition as well.
Yes.
That's a smart move on their part. And hopefully, Charles, that's something that we can look to do as well, to encourage the client, or maybe we have to encourage the lending agencies to understand what is really transpiring here and managing that risk side of it as well. Maybe that's the only way we get that transformation. Another question we have here in the chat is from Lucan Robinson, who's here in Jamaica, and he's asking, what would be recommended, recommended system for like a 45 feet parking basement? So that's about what, like 4 stories down, 45 feet parking basement.
All right, so for 45 feet basement, I would recommend the deep mixing measure. And the reason why I would recommend the deep mix is for you to go that deep with sheet piles, you would bring a lot of equipment in, and with a lot of equipment in, it becomes very risky, because you have to start thinking about the depth of your sheet. You have to start thinking about bracing at different depths. So it becomes a lot more tedious with sheet pile operation. While on a deep mixing, you just auger down to 40 feet, or say 45 feet, you know, at a few feet below what your requirement is. And then you mix with your grout all the way back to your surface. And only thing you have to do after that process is completed is just to do your excavation, and you get down to your basement then.
Excellent, excellent. And again, if there is moisture in the area between that depth, any recommendations there how we treat with that?
So once you deep mix, that everything, water, soil, everything becomes a what is known as a soil creek. So it becomes a solid section. So that water is no longer present in that mix. Excellent,
excellent. All right, so hopefully that answers your question, Luke. And I see a hand up. I'll take the hand before I go to Courtney's question in the chat. Risha, you can unmute and ask a question. You're muted, Risha. All right, so we'll go to the question in the chat, and Risha will come back to you since you're muted. So there's a question here from Courtney Laidlow, which is saying, is there any other smart technology employed in the installation or monitoring of performance of the foundations? For example, in tools or sensors that, or any tools or sensors that can cast into concrete permanently as well? Can be cast into concrete permanently?
Yes, they are. Actually, I don't remember the name of it now, but I could research it. I could actually get it to you in a few minutes and send it to you. So they are typically, for us, what we do, once we get into production, we recommend that strain gauges are installed in these piles. So the strain gauges would give us different readings as the piles as the building gets to certain heights. So the more weight you add to the building, then we are getting that recording on the strain gauge. So we're actually seeing how the piles behave. They actually have sensors that you embed in the concrete that measures the set time or the setting time of the concrete. And you can pretty much get into these devices and analyze how the concrete strength develops as it sets on a day-to-day basis. So they are actually electronic sensors that they have. You embed into the concrete, and it actually measures setting time, and it gives you a comparison between your setting time and the temperature at different intervals.
Excellent, excellent. All right, so that's the last question I have here in the chat. Let me see if there's any other questions or hands up. My team is there with me.
Yes, I think there is another question. Basically, at what height do persons, or do you have to typically do settlement tests at the adjacent buildings?
All right, so we start start monitoring settlement from the very minute you start the construction. So because you want to have an initial data for you to start comparing to. So this is your initial points. Your initial point is once you install your files and you are ready to do your first floor, then we recommend you start monitoring from pretty much that point.
Okay.
Oh, I think they meant at what height do you start doing settlement test? If it's like a 10-story building, or you start doing it if it's like a 30-story building that you're going to build?
No, you pretty much start from the ground floor up. So as soon as you start on the site, you start taking
Now, what size structure is there? A minimum size structure that's required, or let's say we're doing a 5-story versus a 50-story. Is there any distinction that's there, or
no? Typically, on a 5 to 10 story, you look at your settlement based on the type of foundation you're using. So on a typical 5 to 10 story, you'll get an inch of settlement. An inch of settlement typically dissipates by the time it gets to adjacent property. However, you still want to be careful because, one thing here in the US is that every project or every adjacent neighbor you have to think that you're aligned with attorneys. So for the very minute you have that thought process in your head, you still have to just do your necessary checks and balance. So a good old saying that we grow up with is prevention is better than cure, or an ounce of prevention is better than a pound of cure. So we pretty much start taking that necessary plan from the beginning to prevent anything from coming back later on. So you just spend that extra cash, do your monitoring, and then if nothing happens, you put your hands in the air, you walk away a successful developer, and you say, hey, I did what I was supposed to do.
So given the fact that in the US, there's such a strong drive towards litigation versus what may be experienced here in the Caribbean, could that be one of the main reasons why, we appear, let me just use that word, appear to not take as much caution as you might experience in the North American experience?
Yes, I think that's one of the main reasons.
Right. So that's something that we may have to start looking into as well. No, again, we're not trying to get to a point where we're suing everybody. We hope not, but we hope that the ethics and the morality of our designs would drive how we operate as a people, knowing that safety is always number one.
Yes,
and we're concerned about our neighbors in that sense. I see so just a point being made, it's not simply the height of the structure, but preservation of the neighboring structures. Right. So again, in the Caribbean, maybe one of the other issues we have here too, especially when it comes to high rise. Now, as we project towards more and more high rise structures, and for us, high maybe 15, 20 going above, we don't reach the 90 yet. And we may never get there, but we're definitely at the 15 to 20 and projecting even higher structures as well. And these are now being developed in urban areas where there's already adjacent properties in close proximity. So it seems as though there needs to be some transition in how we may operate in that sense as well. Any thoughts you have on that matter?
Yeah, as you explained, safety is first and foremost. So, you have to think about your neighbor as yourself. So if you're doing this development, think about what you would want for yourself in case somebody was doing this. So you have to make sure that you monitor any effects to your neighbor, because, the settlement or the vibration may not only affect, the building itself, but the vibratory level could affect persons living inside the building. So, with all of these constant vibration, you have persons who work at different hours of the night. They could be home trying to get some rest, and you may be doing your installation and your vibratory level has exceeded threshold, and because it has exceeded threshold, these persons can't rest properly. So, safety of the neighbor plays a very important role. So, for me, my recommendation is once you're installing any high rise within these locations, think about your neighbors, do all the necessary plans in place to make sure that your project is done in a safe and timely manner, and it does not cause much nuisance to your neighbors.
Yes, very good. I have two more questions here in the chat. First one is coming from another geotechnical engineer, Charles Allen, and he's saying, have you ever been involved in any projects with the settlement criteria exceeded? And what was employed to address such a situation?
When you say the settlement criteria, is he talking about the adjacent requirement? Because if on the project itself, you design for a certain settlement, you provide that information to the structural engineer, and then he or she will determine if that's adequate for them. Mm-hmm. Now, the criteria, the adjacent properties has certain criteria. if those settlement on the adjacent properties are exceeded, then what you do, you prepare what is known as a mitigation plan. And the mitigation plan is, okay, I expect 2 inches of settlement at this adjacent property. Based on these 2 inches, I expect this building to move X, or I expect this to happen to this building. My mitigation now would be to address those issues. So if I expect cracks, or I expect some displacement of stuff, then I would put plans into place to address this with the neighbor. So I say, okay, based on my development, I'm expecting this to happen to your building. So this would be my plan of action in case this happens.
Excellent, excellent. So that's how you'd address that one. Now, the second question we have here is from Frank Campbell, and he's saying, with regards to the actual design of the pad or pile foundations, determine settlement, etc., is it the geotechnical engineer that does the design or the structural engineer?
All right, so it works twofold. So we do the recommendation and in terms of the size, the length, the grout strength. The structural engineer would include the reinforcement in the pile to give it adequate support. So we would make all the recommendations. So the recommendation for the grout strength would be from the geotech. The recommendation from the length would be from the geotech, and the recommendation for the diameter would be for the geotech. So all of that parameters would be coming from us, the geotech. And all the structure we'll be doing would be adding the reinforcement or beefing up the reinforcement inside the pile itself. In terms of the pile caps are designed by the structural engineer.
Right. All right, Frank, hopefully that answers your question in that sense. Let me see if there are any other questions. Melissa, are you seeing any other questions there?
Yes, Dr. Ellis, with regards to the previous question, what would be, say, a typical plan of action if the settlement is exceeded on the adjacent building?
If you follow the question, Clyde?
Yeah, all right. So if the settlement is exceeded on the adjacent building, then you would look at it to determine what effect does that settlement have on the adjacent building. Because if the settlement has exceeded, then it depending on the supporting soil type and the supporting member of that building, then the effect of the settlement could behave differently. It could behave in the form of cracks. It could behave in the form of differential settlement. So it all depends on what happened as a result of the settlement being exceeded. Based on that, then you would have plans in place. So if there's just cracks, then you pretty much repair the cracks. If it's a case where you have differential settlement, where one side of the building settled on the next, then that case you could use pressure grouting if it's a shallow foundation system to bring back that building up to its normal level, or you could use hydraulic jacks to put it in back to that level, pump it back to the level, and you fill it or you underpin it with grout. So it all depends on what happened as a result of the settlement being exceeded.
Yes, thank you for that.
Any other questions from our listening audience? We had a very, very healthy turnout today, over 90 participants. So Clyde, this is a very sought after topic, clearly, in that sense. So we definitely want to thank them for sticking out with us from the beginning until now. Are there any further questions that we have in the chat? We are just shy over the time period, but that's okay. I think it's interesting enough for us to continue just for a few more questions. We have some congratulatory notes here from Garth Jackson. Thank you very much. Found it very informative and enlightening and well delivered, and the presentation was appropriately balanced and fulsome, and even providing responses to the questions. And similarly, Charles Allen is reiterating the similar comments, and we thank you very much for those regards. Now, as noted, we have upcoming in the development forum series, additional webinars to be hosted every Thursday for the rest of this month. So we invite you guys to come out. You will see more being marketed via our social media platforms, and otherwise, the upcoming one is also scheduled at the same time period. It will be a different link, however, and we will share that link subsequently, but feel free to be a part of that one. We have another one that's civil engineering related the following week, but for those who are in the other disciplines of engineering, we have those two as upcoming events. Melissa, I don't know if you want to just highlight what those are whilst we have the audience still. All right, so she's probably a little bit away from her microphone. So let me just pull that up quickly and just give you a quick update as to what's next. So we have coming next week on the 16th, the potable water, sewage, and subdivisions development application process. For those that are here in Jamaica and want to go through that process, but I'm sure it will be instructive for persons across the region as well. Similar patterns are taken. On the 23rd, we'll have building design, wind and earthquake loads, and that will be done by Peter Jervis and Associates as another structural engineering aspect, now following on the superstructure aspect. And on the 30th, we have going more with the energy, the PV systems, optimal designs, and the real costs and the implications of the development order on the new Kingston and St. Andrew landscape as well. So we have a full spread of the subdisciplines, and we're inviting you guys to join in and be a part of that as well. We have persons who are even non-engineers here from the real estate and other such similar related fields, because naturally they have to sell these structures that we're speaking of, and they want to know and ensure that they can speak to that when guiding their potential clients on the developments, and knowing that all these ramifications that we have spoken of were addressed as the design goes forward. So Clyde, I want to thank you again for sharing your expert knowledge with us. And we hope that, because we have future things, we still want to tackle some other events, and we're hoping that you'll be available and willing to play your part there as an engineer that has designed and worked on a number of these high-rise structures in the future. My name is Leighton Ellis. I am the Civil Division Chair, and thank you again, everyone, for being a part, and we hope to see you in the near future. Have a good day.
All right, thanks.